Chemical reaction can produce impure byproduct. Product may undergo purification to get rid of contaminants and byproduct. One of the most crucial processes for purifying solid organic molecules is recrystallization, which depends on the varying solubilities of solutes in a solvent. The substance is dissolved in a small amount of heat solvent and will continue to crystallize as the solvent cools and the solution becomes saturated with regards to the substance. The right solvent must be used in order for recrystallization to occur. The substance must dissolve in the hot solvent and become insoluble in the same solvent when it is cold. The more product recovered after recrystallization in terms of solvent selection depends on how much the hot and cold solubility differences. The size and purity of the crystal are dependent on the cooling rate. Rapid cooling favors more crystals, whereas gradual cooling encourages the formation of large, generally pure crystals. Additionally, a suitable recrystallization solvent should be partly volatile in order to be readily washed away from the crystal after purification. In addition, the solvent should not interact with the chemical being purified and its boiling point should be lower than the melting point of the compound being.
Tools and apparatus used in experiment 1 are hot plate, glass rod, 25 ml graduated cylinder, electronic balance, Wagner funnel, 125 ml aluminium flask, thermometer, spatula, boiling stone, filter paper and 50 ml beaker. Distilled water, ice cube, salicylic acid, benzoic acid. The first step, 1 gram of impure benzoic acid was weighed on the electronic balance. The next step, 20 ml distilled water was added to the 125 ml aluminium flask. The third step, the mixture was brought to the boiling point by heating on a hot plate with continuous stirring. The aluminium flask was carefully immersed inside the ice bath and was left to recrystallize for 50 minutes. Then, the mixture in the aluminium flask was poured into the Wagner funnel and the vacuum pump was started. The next step, make sure that all the crystals were scraped out of the aluminium flask by using a stirring rod. Then, step 1 to 6 were repeated by replacing with salicylic acid. Then, the next step, the dried crystals were transferred into the filter paper. The crystal is left to dry for 15 minutes. Lastly, the crystals of benzoic acid and salicylic acid were weighed and the weight of each sample were recorded.
So based on this experiment, the result obtained achieved the objective of this experiment, whereas the pure crystal weight obtained for salicylic acid and benzoic acid is 1.4473 gram and 1.2545 gram respectively.
I will explain for the discussion of this experiment. According to the table in the previous slides, the calculated percentage recovery for benzoic acid and salicylic acid are greater than 100% because the crystal of benzoic acid and salicylic acid may contain moisture from water that did not filter properly during the filtration crystal. Furthermore, the filtration process could not remove the water contained in the crystal well and it still have moisture of water. Because the method should be oven to dry well the crystal to get the percentage recovery more accurate and lower 100%.
Recrystallization is a method of purifying a solid organic compound. This process removes soluble and insoluble impurities present in organic compound. Based on this experiment, the soluble impurities get filtered out from filtration process because the impurities still soluble in a cold condition. From the experiment, we get disappointing result because the percentage recovery of benzoic acid was 124.83% And for salicylic acid, the result was 144.01%. Both result is access than 100%. One of the reasons why we obtain such as a disappointing result is because we didn't vacuum truly enough, and the crystal also has not fully dried. That's all for me. Thank you.